Hi again, third period. So I also had a request to explain how to do numbers 1 and 2 from our 6.2 homework, because there will be a question like these on your quiz on Monday. So let me begin by going over number 1, and then I'll also show number 2. So the way I do these, and keep in mind there's more than one right way, so some of you may have done it differently and gotten an answer that works, and that's totally fine, because there's also more than one right way to write your final equation also. But the way I do it is I tend to focus in on the point that I can see that's closest to the asymptote, and I use that point to tell me both what I'm going to use for H and also what I'm going to use for A. So the coordinates of this particular point have an x value of -1 and a y value of what looks like -4.5. So I use the x coordinate of that point as my h, because I like to kind of think of it as the middle. Like if I were to just sort of cut this in half, the right side is the part growing really fast, and then the left side is the part that's not going fast at all. And h is sort of the middle where that change happens. I use the distance between that point and my asymptote as a. So it looks like a is 1/2 based off that point and how far away it is from the asymptote. And then the asymptote itself is what I use for my k value. So once again, I use the coordinate, the x coordinate of the point closest to the asymptote as h. I use the distance from that point closest to the asymptote and the asymptote as a. And I use the value of the asymptote as k. So I gather all of that information from my graph and then I put it into my template. So the template is, you've got a times your base. Your base is being raised to the power of x minus h, and then after that you're adding k. So in this case, I'm using 1/2 for a. That is getting multiplied to the base, which I don't know what that is yet. But the base is being raised to the power of x minus h, which in this case is -1. All of that's in the exponent. And then I add k, which in this case is -5. Okay, so now what I have after putting in all that information for number 1 is I have y equals 1/2 times the base b raised to the power of x plus 1 and then -5. So I know every part of my equation except for b. So what I'm going to need to do to find b is locate another point on the graph. And I usually, for that point, I usually like to use whichever one was closest to h. It doesn't matter though, but that's just what I tend to try to use. So the coordinates of that point are 0 for x and then -3.5 for y. 2, 3. So I will plug those x and y values in to the equation in place of x and y temporarily so that I can figure out the value for b. And so I end up with this equation where I have -3.5 on the left equals 1/2 times b, because 0 plus 1, that just equals 1, and b to the first power is just b, minus 5. So it ends up just being a linear equation, and I can just add 5 to both sides. And then -3.5 plus 5 would be 1.5, and then that equals 1/2 times b. So then I could multiply both sides by 2. The 2 will cancel with the 1/2. 2 times 1.5 is 3. So then my base for this one, number 1, must be 3. So then my final equation would be what I get when I plug everything in. So my a value of 1/2, my b value of 3, my h value of -1, and my k value of -5. That would be my final answer for graph number 1, or at least one of the possible final answers for the graph in number 1. Okay, so this was the equation that I got when I did number 1 my way, but this is another equation that would also work. That is maybe something one of you got. And there's, again, other ways of expressing this equation. These are actually equivalent to each other because I'd be adding these powers of 3, right, to get the x plus 1. But you don't have to simplify it that way. I just want you to realize the reason you can write these in different ways is just because of those rules of exponents. So anyway, that was number 1. Now I want us to take a look at getting the graph for number 2 using the same strategy. So again, the strategy I used before was I first sort of honed in on the point that I could see that was closest to my asymptote. And then the coordinates of that point, I have 4, 2. I use the x coordinate of that particular point as my h, because I'm going to use that point to kind of help me decide where the middle of my graph is, where the quick increase kind of starts changing into a slower increase. Okay, so I'm going to use my h value, or for this one, my h value is going to be 4. Then I use the distance between that same point and the asymptote, so this distance of -2, as my a value. The reason I'm using negative is because this time I have to go down from the asymptote rather than up. In this last one, I went up from the asymptote, and that's why a was positive 1/2, because I had to go up 1/2 from the asymptote. But in this scenario, I'm going down 2 from the asymptote. So for that reason, I'm going to use -2 as my a value. Then for the k value, it's just the location of my horizontal asymptote, which is at +4. So that will be my k value. And then I begin by writing that into the template. So it's a times my base b, which I haven't found yet, to the power of x minus h, and then plus k. And again, the way I'm doing it is where my h is going to be 4 and my k will be 4. So then my b is going to depend on what I chose for those, and then also what the other points on the graph are. And I like to choose the point closest to h, so that way that this power won't be too big. So I'm choosing this point where I have 3 for my x coordinate and 0 for my y coordinate. So I'll plug 3 in here for x and then 0 in here for y. And then that turns into an equation where I will be able to solve for b. So I get 0 equals -2 times b to the power of -1 plus 4. And then I can subtract 4 to the other side. I can divide both sides by the -2. And then I have to remember what it means to have b to the power of -1. That is the equivalent to 1 over b. So this is what I know. I know that 2 is equal to 1 over b. So I know that 2 times b must equal 1, because I'd have to basically multiply b to both sides to cancel it out. And then to solve for b, I divide by 2. So my base for this one is going to be 1/2. So here is how I would write my final answer with everything plugged in. So again, my a value was -2. My base was 1/2. My h was 4, and my k was 4. So this is one possibility for an answer. But there are other options. So because there's other points you could have used to be like the h, where the h value is, and that would give you a different a value and stuff like that. So here's another possible equation. So you could have had A as -1. And then if A were -1, then your H would have to be 5. You'd have to be using this point as your middle. But that could work and would still match all the other points on this graph. So here's another equation that you could have used. Or another option is you could have used A as -4, and then your H value would have to be x minus 3. And then your K value would have to be 4. So like all of these different variations are all possibilities. They are actually all equivalent to each other. They all, if you typed them each into Desmos, they all would give you this exact same graph. But here I was just showing you one process that you could use, and that process got me to this equation. So feel free to use my process if you weren't able to get an answer on your own. But if you were able to get an answer on your own that was also correct, feel free to keep using your same process. And then again, Quiz Monday, it will include section 6.2, and I'll see you then. Bye.